We're going to be doing the hydrolysis of salts simulation and collecting some pH data, which you will use then to characterize how salts interact with water and whether they form acidic or basic solutions and how we can predict that. So first thing I just wanted to go over before we look at the simulation, how to figure out what the origin acid and origin base are. So you are told in the lab handout and in the simulation handout that NH4+, if you see that as the cation, that one's going to be a little bit different to determine the origin base. The origin base for the ammonium ion is actually going to be ammonia, which is, again, if you look at the difference between the formulas NH4+ and NH3, if you take away NH+, you end up with NH3. So that's going to be the origin base if you see the ammonium ion as a cation. If you see something else as a cation, let's talk about that. So the idea is that we want to trace back the salt components, that if they had come from an acid or a base, which acid or base would they have come from? So when I look at this example here, so LiBr, so that's lithium bromide. So you're always going to take the cation and figure out what base would that be if I had that cation with hydroxide. So lithium with hydroxide would be LiOH. So this would be the origin base for this one. From the list that we have memorized, we know that this would be a strong base. And again, you can reference your notes if you don't have that memorized. Secondly, then we look at the anion part of the formula, and that is bromide. So we think about, well, what would that be as an acid? It would have the hydrogen as the cation, and so that would be hydrobromic acid as the origin acid. And again, if we think about, we can go back to the list of strong acids, and hydrobromic acid is on that list, so that would be strong. Again, anything that's not on the strong acid or base list, you can consider them to be weak. Don't forget to factor in the charge of the cation or the anion. So lithium, being a alkali metal, has a +1 charge. That's why I only used one hydroxide in the formula. If I had something like Fe2+, well, let's just do an example here. Let's say I had FeBr, 2 as my formula. The origin base, so again, I take the iron, and notice that if it's with the 2 of the bromides, then it would need 2 hydroxides, and so I'd put that in parentheses there. So that would be the formula for the origin base, and then again, since the Br is the bromide ion, that would be HBr. So notice that even though in the original salt, Br had a 2 next to it, that's because the iron has a +2 charge. When I write that as the acid, we're just writing it with 1 H+ and 1 Br because there's a +1 and -1 charge. Okay, so now we're going to start collecting our data. So I'm not going to talk through this, I'm just going to go in the order that they are on the sheet, and you can record the pHs as we go. So they'll write down the list as they appear on the table